Welcome to the 68th lecture on digital electronics. In this lecture, we are going to deal with an important application of multiplexers. That important application is logic function generation. That is, if you are given a logic function like f is equal to sigma m 1, 2, 3, etc., how to generate that function or the output of that function using a multiplexer. That is a key point which needs to be dealt in this lecture. So I will directly go into an example, and from there we will learn further. So coming into an example, the question is realize the following function using 8x1 multiplexer. The function is given as f is equal to sigma m 0, 2, 3, 5. That is a function. Okay. Now this is given in min-term expressions or SOP form, sum of products form. So here what you can see is that m0 is equal to 1, m2 is equal to 1, m3 is equal to 1, as well as m5 is equal to 1. All other terms become 0. That is m1, m2, m3, m4, m5, m6 and m7. These four terms are 0. Okay. Now coming into the truth table of this expression, you are having how many inputs for this 8x1 maths, or if you need to realize 0, 2, 3, 5, you should have at least 3 inputs. These 3 inputs or 3 Boolean inputs, these 3 Boolean inputs you can choose it as selectors. You can choose that 3 inputs as selectors. Okay. So I am choosing a selector here. Okay. So selector, output I am taking it as F. So which are the 3 selectors? What I am having is S3, S2 and S1. So 0, 0, 0, 0, 0, 1, 2, 3, that is 0, 1, 1, 3, 4, 5, 6 and 7. Okay, that is a decimal equivalent, and if you are that is a Boolean equivalent, and if you are writing the decimal equivalent, you will get as 0, 1, 2, 3, 4, 5, 6 and 7. Now see, m0 is equal to 1. That means you will get for this 0. That means here what we get? This is 0. So you will get 1. m2 is 1. m3 is 1. Yeah. m5 is also 1. All other terms are 0. All other terms are 0. So you will get 0 here. 0, 0, 0. So that is the basic truth table. And you are having selectors also. Now, how to realize this function using a multiplexer? That is the question here. Okay. So for realizing a 8x1 multiplexer, so you are having 8 inputs. So to realize an 8x1 multiplexer, you should have 3 selectors. That 3 selectors already you have is S3, S2 and S1. Okay. Now I am having 3 selectors, and how much data? 8 data. Should have 3 selectors and 8 data. Okay. So that 3 selectors I am choosing as what? Which are the 3 selectors? S3, S2 and S1. Choosing it as S3, S2 and S1. Right? So how many data are there? See, here the data means like say D0, D1. Write in another term. This is D0, D1, D2 D3, D4, D5, D6 and D7. So here we can see that data D0, D2, D3 and D5 is 1, right? And D1, D4, D6 and D7 is 0. So you can have a 1 here. Okay? You can have the points D0, D1, D2, D3, D4, D5, D6 and D7, right? And 1 is given to D0, then D2, so D2 the value is 1, then D3 the value is 1 and D5 the value is 1. For all others the value is 0. So you need to give 0 to other elements. So how to give, you can give 0 to the other elements. So 0 is here. 0 you can give it to, first one you can give it to D1. D2, D3 is 1. Then 0 is given to D4. Then 0 is given to D6. Then 0 is given to D7. Okay. If you are drawing it correctly, the value is 0. Okay. And you can get the output Z. This is the output. That means here when S3, S2 and S1 is 0, when S2, S3 and S1 is 0, you will get D0. So what is the D0 value? D0 you will get it as 1. That means when S3, S2, S1 is equal to 0, the data corresponding to D0 will come out. What is the data corresponding to D0? It is 1. So D0 is 1. Similarly, when S3 is 0, S2 is 0 and S1 is 1, the data corresponding to D1 will come out. What is the data corresponding to D1? It is 0. Similarly, when S3 is equal to 0, S2 is equal to 1 and S1 is equal to 0, the data corresponding to D2 will come out. So what is the data corresponding to D2? It is 1 to come out. So that is the order in which this function is being realized. So this is basically an 8 by 1 multiplexer. Hope you have understood the concept of realizing the function using an 8 by 1 realizing a simple function using multiplexers. Going into the second question. Realize the following function. Realize the following function using 16 by 1 maths and 8 by 1 maths. Okay, that is the question. So the question is f is equal to sigma m 0, 1, 2, 3, 0, 1, 2, 3, 4, 10, 11, 14 and 15. So now first I am going to deal with 16 by 1 maths. Okay. For a 16 by 1 maths, the minimum number of select switches required is 4. So you need to have 4 select switches. Whereas for 8 by 1 maths, you need only 3 select switches. Okay. So these are the number of selectors. Okay. 16 by 1 for 16 by 1 it is 4, and whereas for 8 by 1 it is 3. Now let me draw the truth table of the given function. Okay. So I am having 16 data. So these are the selectors. Okay. This is output. This is output. Okay. So I am having, like for the first one, so I am going to realize using 16 by 1 maths. Okay. So this is I am having S3, S2, S1 and S. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7 and 8. 0, 0, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. 0, 0, 1, 1. 0, 0, 1, 1. 0, 0, 1, 1. 0, 0, 1, 1. Next one is 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, and 1. So if you are looking into this, you can if you are writing the decimal equivalents, you will get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. That are the corresponding decimal equivalents. Now if you are writing the corresponding outputs, for 0 you have value 1, 0, 1, 2 and 3. 2 and 3, the output is 1. Then 4 also the output is 1. Then comes 10. For 10 output is 1. For 11 output is 1. For 14 output is 1, and for 15 the output is 1. For all others, the output is remaining as 0. For all others, the output is 0. Then here we get 0. 6 is 0, 6, 7, 8, 9, 12 is 0, and 13 is 0. Okay. So for all others, you are getting it as 0, right? For 5, it is 0, 6, it is 0, 7, okay, 7 I have over 7, it is 0, 8, it is 0, 9, it is 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, that's it. Now coming into the output is Z. So how we can realize it using a 16 by 1 maths? So we can draw a 16 by 1 maths directly. So 16 by 1 maths. Okay. And we can take the data as like this. We can take the data as D0, D1, D2, D3, D4, D5, D6, D7, D8, D9, D10, D11, D12, D13, D14, and D15. Right? So we are having 16 inputs. So it is D0, D1, D2, D3, D4, D5, D6, D7, D8, D9, D10, D11, D12, D13, D14, and D15. So which are the selector switches? You are having selector switches as S3, S2, S1, and S0. That are the selector switches. Okay. So for which all values you should have 1. 1 is attached to D0, D1, D2, D3, D4. Then comes D10, D11. Comes to D10, D11, then D14 and D15. Okay. For these much values you should give the input as 1, and for all other values you should give the input as 0. Okay. For all other values the input is 0. So you will get D5, D6, D7, D8, D9 it is 0. For D12 it is 0, D13 also it is 0, and you will get the output as Z. The output is Z. So you get the output. Okay. This is how you can realize the 16 by 1 maths using 8 by 1 maths. So you can realize the given function using 16 by 1 maths. Okay, because this is a 16 input, or you are having 16 inputs, you can realize this function using 16 by 1 maths. Now coming to realization of the same expression using 8 by 1 maths. So here there is a constraint. What is that constraint? The constraint is we can use only 3 number of selectors. That is the constraint we have. So the realizing the same function using 8 by 1 maths. Okay. Now, what is the constraint we have? The constraint what we are having is, we are having only 3 selector switches, whereas for 16 by 1 mux we are having 4 selector switches, and the constraint what we are having is, here what we are having is, we are having 3 selector switches. So what I am going to do is, I am going to make the 4th selector switch as an input. Okay, so I am going to do like this. So I am having selectors. Okay, so which are selectors what I am having is S3, S2 and S1. I am having only S3, S2 and S1 as selectors, and I am taking another input say X. Okay, and output is Z. So I am just drawing the truth table first, then we will go further. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 0, 0, 1, 1. 0, 0, 1, 1. 0, 0, 1, 1. 0, 0, 1, 1. Again, now you are having only 3 selectors, and you can take here like this: 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay, so I am compared with the 16 by 1 mux, I am taking the 1 selector switch of the 16 by 1 mux, that is S0, and making it as input to the 8 by 1 mux. That is the idea over here. So what is the function what I have? Function is f is equal to sigma m 0, 1, 2, 3, 0, 1, 2, 3, 4, 10, 11, 14 and 15. This is the function which I am having. Okay, so now I am just giving the outputs. Okay, which are the outputs I am having? And D0, this is like you can enter 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. That is the decimal equivalent. Okay, for D0 my output is 1, D1 it is 1, D2 it is 1, D3 it is 1, D4 it is 1. For D10 it is 1, for D11 it is 1, for D14 1, and D15 the output is 1. For all others the output is remaining as 0. 0, 0. Okay. Now, how to select these outputs? That is a big question. What is coming in? So I am drawing a table like this. Okay. Right. So here I am having D0, D1, D2, D3, D4, D5, D6, D7, D8, D9, D10, D11, D12, D13, D14 and D15. Okay. So you already know that D0, D1, D2, D3, D4, D10, D11, D14 and D15 the values are 1. Okay. Now I need to realize it using realize the 16 by 1 mux using 8 by 1 mux, the logic. Okay. Now I am taking the output is D0. Okay. So here I am having output in terms of F. Okay. So I am taking two elements each. Okay. First 2 elements I am taking. Okay. Here what is the output? The output is remaining as 1. Next 2 elements, these 2. What is output? The output is remaining as 1 only. Next 2 outputs. Is there any specialty here? See, the specialty what you can see is here S is 0 and 1, whereas here the output. So again output as F, f it is changed as 1 and 0. That means when h is 0, f is 1, and when h is 1, f is 0. So here what we can write, f is equal to h bar. Similarly, here what happens? Here what is the value of f? F is equal to 0. Here also what is the output? Output f is equal to 0. Here what is the output? Here the output is f is equal to 1. Output is equal to 1. Here what is the output? The output is f is equal to 0. Here what is it? F is equal to 1. That means only in this case you should give the h as input. All other cases you can take it directly, right? Okay. So here we can take for the 8x1 maths. For the 8x1 maths, what we can take it as, this is D0, this is D1, this is D2, D3, D4, D5, D6 and D7 for the 8x1 maths with the 3 selector switches, that is S3, S2 and S1. So I am drawing an 8x1 maths. I am drawing an 8x1 maths with the inputs as D0. Okay, so I can write the inputs like this. Okay. So I will give the inputs as D0, D1, D2, D3, D4, D5, D6 and D7. The selector switches are S3, S2 and S1. S3, S2 and S1 are the selector switches. Okay. So what is D0? So we are having 1 and 0. D0 is, so for 1 you can give it to 1, you should give it to D0, D1, then that is 1, D5 and D7, D5 and D7. You should give the values as like this. 0 you can give it to where? 0 you can give it to D3, D4 and D6. 0 you can give it to, one second, I will choose another color. 0 you can give it to D3, D4 and D6. Now what is the D2? D2 is basically H bar. So you give H bar as input to D2. You give H bar as input to D2. That is it. Okay. That means when H is equal to 0, you will get the output as 1. And when H is equal to 1, you will get the output as 0. Okay. And here you can get the output as Z or F. Okay. So this is how to realize this function using realize the same function using 8x1 maths. Okay. That means if you are having a 16x1 maths function which needs to be realized by 8x1 maths, reduce the number of selectors to 3. So here I am having only 3 selectors. Reduce the number of selectors to 3 and take the 4th selector of the 16x1 maths as one of the inputs. Okay. And write the output in terms of input if possible by taking this 2x2 combination. So that is the basic behind it. Okay. So I think you have understood the concept of this realization of the maths. Okay. Now coming into third question. Third question. Realize the following function using 4x1 maths. Okay. So the function is given by f is equal to, or f of a comma b comma c. F of a comma b comma c is equal to sigma m 1, 2, 4, 7. Okay. Now, here what is the problem? The problem is you need to realize it using 4 by 1 maths. Okay. So if it is 4 by 1 maths, the data what we are having is D0, D1, D2 and D3. Only 4 data can be fed in. And how many selector switches? Only 2 selector switches for here. For 4 by 1 maths, we are having 2 selector switches. Okay. But here it is basically, if it is, here you are having 7 data effectively. And you need to realize it using a 4 by 1 maths. That is the question. Okay. So first of all, let me draw the truth table. Okay. And you have remember that you are having 2 selectors only. Okay. So if you are having 2 selectors, okay, or just okay. So before finalizing the selectors, let me draw like this. Assume that I am having only 3 inputs. Okay. So this is input and this is output. Output I am writing it as F. So I am having 0, 0, 0, 0, 1, 1, 1, 1. So this is 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1. If you are taking the decimal equivalent here, you will get this is 0, 1, 2, 3, 4, 5, 6 and 7. Now what are the corresponding outputs? Okay. For D1, for 1 it is 1. For 2 it is 1. For 4 it is 1. And for 7 it is 1. For all others the value is remaining as 0. Right? 0 and 0. For all others the value is remaining as 0. And again the same problem comes. You are allowed to use only a 4 by 1 maths. That means you are having only 2 selectors. Okay. That means here you need to choose selectors as these 2 are the selectors. Selectors as this one only, S2 and S1. The last one you should choose as an input. Again, you do the same thing. Select 2 by 2 means 2 each. Select 2 each. Do the same thing. Okay. This is an input X. You can take the input as X. Now, here, what I can have? I should write in terms of input. F should be written in terms of input. Okay. So here, when F is 0, when H is 0, F is 0, when H is 1, F is 1. So you can write F is equal to H. Here. Here what happens? When H is 0, F is 1. And when H is 1, F is 0. What is it? So you will get F is equal to H bar. Here, what happens? 0, 1, 1, 0. Again, what happens? F is equal to H bar. Here 0, 0, 1, 1. Directly F is equal to X. Okay. Now, for the 4 by 1 maths, this is D0, D1, D2 and D3 with the selector switches as S2 and S1. That means when S2 is equal to 0 and S1 is equal to 0, D0 will be selected. When S2 is equal to 0 and S1 is equal to 1, D1 will be selected. When S2 is equal to 1 and S1 is equal to 0, D2 will be selected. When S2 is equal to 1 and S1 is 1, D3 will be selected. And again we are manipulating the data coming in. That's it. So I am having that 4 by 1 maths. I am having that 4 by 1 maths with selectors as S2 and S1. Selectors as S2 and S1. And I am having how many data? D0, D1, D2 and D3. Now let me take the data. How to take the data? You take the data as only H and H bar. H is there and you can note it, or you can take another H bar, no problem. H is given to D0 and D3. D0 and D3. That is H. And H bar is given to D1 and D2. H bar is given to D1 and D2. Okay. That means here what we can see is that when S2 is equal to 0, H1 is equal to 0. what happens? Whatever is in X, it will come out. Okay, whatever is in X, it will come out. It can be D0 or D3. Whatever it is, it will come out. Whereas if S2 is equal to 0 and S1 is equal to 1, or when S2 is equal to 1 and S1 is equal to 0, whatever is there in X bar, it will come out. So we can get the output. This is the output Z or output F. So this is the realization. This is the basic realization of the given function using 4 by 1 months. So here, since you are having 1 to 4 and 7, it is basically an you should count from 0 to 7. That means you should have 8 inputs. But the question is, make it into 4 number of datas and 1 output. Okay. So that is a basic thing here. And again, that too again with only 2 selector switches. Okay. So coming into next question. Okay. So I think we can stop here. Next question we will deal in the next lecture. So here what I have done is I have given some examples. So how to realize the given function using a math. So the math is given as first the function is given and the corresponding math is formed. If nothing is specified, you find the number of inputs and make it into a number of inputs by 1 math and give the selector switches. Otherwise, if you need to realize it using less number of using a math which is having less number of inputs, try to combine it. Okay, that is what I have. Try to combine it like this. Okay, so if the 16 by 1 math needs to be the data of 16 by 1 math needs to be realized using 8 by 1 math, you take 2 by 2. You take 2 each. And make one of the selectors of the 16 by 1 maths as the input of 80 as one of the inputs of 8 by 1 maths. Okay, probably the last bit. Okay, now coming into next one. Okay, this question I have taken the idea from here. Okay, so with that I am stopping with this lecture, and in the next lecture we will deal with some more problems in realization of this logic function using multiplexers. After that we will start with DMAS. Okay, thank you.